Let's do some examples now. So we have the function y is equal to 3x to the fifth minus 20x cubed. We need to determine what the stationary points are. We need to find out whether those stationary points are maximum or min. And we need to determine the points of inflection, or to find possible points of inflection. So to fulfill our first objective of finding stationary points, we're going to be finding dy by dx and equating it to 0. So dy by dx would be equal to 15x to the fourth minus 60x squared. Now let's equate that to 0 and do some factorizing to determine the roots of this equation. So we have, let's factor out the x squared. Let's factor out the 15x squared, and we're left with x squared minus 4 close bracket. And we're going to be equating that to 0. So what would the roots of this be? The roots would be x equals 0, x equals 2, and x equals negative 2. So here we have 3 roots of the first derivative. In other words, we have 3 values of x for which the first derivative will be equal to 0, and as such those are the values of x for which the function y equals 3x to the fifth minus 20x cubed would have a gradient of 0, or that would be a stationary point. So what we do now, we need to determine whether these stationary points are maximum or min. So let's go about doing that by finding the second derivative. So let me just clear right here. So we find the second derivative now by differentiating the first derivative. D squared y by dx squared would be equal to 60x cubed minus 120x. So there we have the second derivative. Now let's plug these values in there. For x equals 0, the second derivative is equal to 0. For x equal 2, the second derivative is equal to 240. And for x equals negative 2, the second derivative is equal to negative 240. What is this implying to us? We're seeing, first of all, that the second derivative at 2 is a positive number, implying that this is a minimum. And here, the second derivative at this number, the second derivative at this very stationary point, negative 2, is a max. Why? Because we get a negative number. Now, note, we're not going to do anything with this right now, with the fact that the second derivative at 0 is equal to 0. We're not going to do anything. We're going to pause for a minute with that. And what we're going to do is that we're going to come down here and find the inflection points. Because remember, the inflection points are given for values of x for which the second derivative is equal to 0. So notice that the second derivative of 0, second derivative at 0 is equal to 0. So that is suggesting to us that quite likely 0 is a possible inflection point. But let's carry out the actual process to determine whether or not 0 is actually an inflection point. So we have the second derivative, which is 60x cubed minus 120x. We're equating that to 0 because we want to find the value of x for which this is 0, or the values of x for which this is 0. So we're going to factor out 60x. And we're going to be left with x squared minus 2. All of this is equal to 0. So by factorizing now, we come to see that the possible values of x that make this equation true will be x equal 0, x equal root 2, and x equal negative root 2. Note that 0 is both a point of inflection, or a possible point of inflection, and a stationary point. So yes, this video is getting too long, so we're going to do another example in the next video.